Alexandra Volta. But later, they said what they call potential energy can also be called what? This potential difference can also be referred to as voltage. In today's class, we'll be looking at AC circuit. The term AC simply referred to as alternating. So here, we are dealing with an alternating circuit. An alternating circuit is the one in which an alternating current will flow. When we talk about alternating current, what we mean is this. The word current simply refers to as flow. So if you don't really get the meaning of current, you can check the first video that we made on electricity. So here, when we say something flows, like our fluid, like water can flow, if you look at one of these illustrations that we made earlier, imagine that we are having a plane surface, a table with end A and end B. In electricity, we call the ends, we call them terminals. When the two of them, when they have the same height, you remember there is a kind of energy associated with height. That energy is called potential energy. Meaning that if the potential energy here equals to the potential energy at the other terminal B, what will happen is, whatever we pour here, even if we pour water here, or we pour electrons here, or we pour charges here, they will not flow. Under what condition will they flow? According to Alexandra Volta, he believes that if I can let A go up, meaning it should have higher potential energy than B, in short, one of them should go up and have a higher potential energy. That is, we should try to bend it like this, such that A will be up and B will be down. Whatever we place here will flow now. Why? Because there is difference in the potential energy at the two terminals. This flow that we happen here depends on the difference that we have. So that means that as this guy is going, work will be done. And the amount of work done depends on the difference between the two potential energy. So instead of saying potential energy difference is what causes the flow here, I would rather say potential difference. So meaning I can say potential energy is also called ordinary potential. The potential difference here was now measured in volts in order to honor Alexandra Volta. But later, they said what they call potential energy can also be called what? This potential difference can also be referred to as voltage. So it means that before current can flow, there must be potential difference across the two terminals. When these charges are flowing, they can only flow from A to B, but they will never flow back from B to A because of the potential difference. But in another way, when we are able to create another system where current want to flow, we are able to consider a hill that looks like this. Then we now make something else to look possibly like this. Then we make another one to look possibly like this. Try to drop a small charge here or a ball. This guy will flow down in this direction. Then the energy it acquired in flowing down here will enable him to be able to move up here. Then the guy will still be able to flow down here. In this case, we are not just going in one direction. We go down, we go up. We go down, we go up. We are alternating between down and up. Hence, the word alternating. The fact that the charge is flowing, the word the word current, So therefore, when I say alternating current circuit, I mean a circuit in which alternating current is flowing. Against the case that we have here, if I call this alternating, what will you call this one? Only one direction. I think I can call that a direct current. So the source of a direct current can just be that one place will be long, the other place will be short. Therefore, the symbol for a direct current is like this. and we try to call it a DC. One is longer, in this case that's the end A. The other one is short, that's the end B in this case. So current will flow from the longer one to the shorter one when we connect it to an external load. So this is a DC source, direct current source. In an alternating circuit, we go up and down, just like our wave, like a sinusoidal manner. So what we have in this case now, we can represent here also with a symbol. So that symbol can now look like something of this type. Since current goes up, come down, goes up, come down. So in an alternating current, we can therefore conclude that the symbol should be something like S, or like the normal wave that we have shown before. Then I circle it like this and like this. So this is the source of an AC. Then in an AC, I have a particular potential difference of voltage produced. But remember that we are going up and down like a wave. A particular frequency must be associated with it. But this frequency, are we going to have it in a direct current? No, because direct current only flows in one direction and there is no frequency. But in an AC, there is always a frequency associated with the source of our voltage. So let's look at a typical circuit in which an AC current is flowing through. If I decide to look at the movement of my current in an AC circuit, I am going to have an axis like this, which is like our y-axis. Then I will have my x-axis this way. If the current leaves a source, it looks like this. Then I can see that the current, as it flows, it makes a particular angle theta with the horizontal, and this is the y-axis. Then what we compare this y-axis to and this x-axis to, they are two different things. The y, if you look at the flow from here to here, this is the maximum value that we can have. You know, before it now fall down, get to 0, get to minimum, get to 0 again, maximum, 0, minimum, like that. Then it will be alternating between them. This place is called the maximum. Either we call it maximum or we call it peak. Peak is another word for maximum, like peak milk, possibly maximum milk. So if I call this one the peak value in a circuit whereby the current, you know, symbol for current is I and symbol for voltage is V. So if I consider the current flowing through the circuit and I call it I maximum, meaning maximum current at this point. But before then, you are preparing for an exam and then you start reading your book. You want to go to 30 chapters. You spend one day on 10 chapters. Then you spend a week, probably during festival, a week on one chapter. If somebody catch you when you are spending 1 week on one chapter, if your daddy just return back from work to spend the holiday with you, he will never pay your school fees again. He believes that you are useless, that you don't work, that you play with majority of your time. But you, if exam come out and you write, your daddy will think you've cheated in the exam because your cumulative value is much. But as at the time he was with you, you were not doing anything. Imagine your daddy came when you were reading 10 chapters in a week. He would have given you his whole salary for like 1 year, that you are a good child. But no, that doesn't happen in most cases. Imagine again, in a case where I am meant to start reading by 10 p.m. at night, and I'm meant to stop reading by 6 p.m. in the morning, then I now, from that 10 a.m. and 10 p.m., I have read from 10 p.m. to 5 a.m. Then I decide to play game or press phone. As I just open my PS, as the PS is loading, then my mother opened the door and comes in. At that instant that she came in, she believed that I have only played game from 10 p.m. till now. She doesn't know that I was reading before. At a particular time, we give consideration to a particular time in science. At any particular time, whatever is happening at any particular time, we call it a name like this in science: instantaneous value. So instantaneous value is any value at a particular time. It means that before I am able to accumulate this maximum value of current, I was actually accumulating them gradually. If somebody comes to me and targets any time, that particular value will be called what? Instantaneous value. It does not determine my overall value because it might be small and it might be big. So therefore, whatever you want to place on y-axis in an AC circuit, we call it instantaneous value. Whatever we have here, of course, it's obvious. We call it the maximum, or we call it what? The peak value. So what I have here now, I am going to call it instantaneous value. If I am working with current, I call it instantaneous value of current. While whatever is here, I call it the peak value. So let me use I naught to denote this. The instantaneous value that we have is the value that we have on the y-axis. Now, while the value that we have here is always the maximum or the peak value. So the peak value is I naught or the maximum value. While the value that we have here is the instantaneous value. So if I am considering a graph of current, I will call any value here what? Instantaneous value of current, and I will call any value here maximum or peak value of current. How are the two related? We just need to remember simple arithmetic. Let me bring out this particular same diagram. Let's assume that I rub here off now. If I rub this off, you can see clearly that the diagram looks so much like a right angle. And some of the angle in a right angle must be 90. So the value that is here is the peak value or the maximum value. And I want to resolve it to the y-axis. If you are doing this resolution and you are having angle with the horizontal, any resolution here is going to give us a value like this. The value that is here, when I resolve it here, is going to become I sine theta. And that value will be on y-axis now. But who is y-axis on the norms? I instantaneous, have you? So that means that my current here, the instantaneous current, will now be equals to maximum current sine theta. That's what we are going to have there. If you know this, you can try to remember one event that we call angular velocity. And symbol for angular velocity is omega. It looks like W. But then it only looks like W, but it is pronounced omega, the last Greek alphabet. This omega is always equal to the angular displacement over time taken. Therefore, I can say that this theta from here is equal to omega t. Instead of placing my theta here, I can now substitute the value to be omega t. Therefore, instantaneous value of current is equal to the maximum value of current sine. Instead of writing theta, what will I write? Omega t. So this is how we create an expression. So from this simple expression that we have created, the value here is called what? Instantaneous value of current. Why the value here is called the peak or maximum value of current? The value here is omega, and y here is t for time. The omega t is the same as theta, and you can replace that with theta. This particular expression that I have created, I can create similar things. If what is here, I can create the same thing for my voltage too. So I remember I told you that current and voltage, they go hand in hand. So if I now say that what I have now is voltage, and what I have here is also voltage or potential difference. The voltage here will still remain the what? The instantaneous value. While the voltage here is still the what? The maximum or the peak value. I mean, if I do the resolution from here too, I am still going to have that my voltage from here, which is the instantaneous value, is equal to what? According to what we have done here, if you resolve it here, it will be V naught or V maximum sine theta, where theta is what? Omega t. So therefore, the instantaneous value of voltage equals to peak value of voltage sine omega t, where omega is the angular velocity and time is the t is the time taken. So these two equations are very, very important that we know. But then, according to the illustrations that I've given you earlier, do you think that any instantaneous value can be used to determine the actual event? We don't want to agree with that, because if I consider reading and playing the game, the result I will get depends on how long I have read. If I do more of reading, then at the end of the day, I will see the results here. If I do less, I will see the results here. So whenever I want to talk about voltage or current, I prefer to talk